Thanks, everybody. Welcome to the Analytics and Data Oracle Community TechCast series. This is your premier access to leading-edge Oracle tech stack content. My name is Peter Katrubis. I'll be your host for today's Analytics and Data TechCast. I'm an Oracle professional and longtime associate, volunteer, and current board member of AnDOUC. Next slide, please. Now, we're pleased to have our industry colleague in Oracle ACE, Kai Yu, present on leveraging vector search for RAG and generative AI. After which we're going to have a brief Q&A. But before that, we're going to have a little bit of an introduction here. What we're looking at now is the TechCast website. All of our TechCasts are recorded. They can be found here. So anybody who's interested in content, you can come out here and see all of our past TechCasts. Anybody who's actually got Oracle expertise and is interested in doing a TechCast, we encourage you to go ahead and submit your topic here. That'll go to the review committee, and they'll get notify you if you've been selected and get scheduled for a similar webinar. Next slide, please. This is a way to connect with us. We've got a lot of different channels, starting with our website. We encourage you to go do that. We have also a Slack channel, which you're welcome to join. All of our videos are posted on YouTube, so you can consume our content there. You can also find us on X, Facebook, and LinkedIn. So we certainly invite you to come and join one of our communication channels and get connected. Next slide. But again, this presentation will be recorded. It'll be available on the TechCast. There'll be a PDF version of the actual slide deck, and then it'll be posted at a later date on YouTube and the other channels. This is a slide on Data Visualization Challenge. Get recognized for your Oracle analytics skills, and this is going to be running February 3rd through the 28th, and we encourage you to participate. Next, please. Now, we're welcoming you to today's TechCast. It's my pleasure to introduce Oracle ACE, Kai Yu, for his presentation on leveraging vector search for RAG and generative AI. Kai has 30+ years of experience in information technology. He specializes in Oracle database, cloud, apps, AI, machine learning. He is an Oracle Cloud Infrastructure Generative AI certified professional, co-founder and vice president of the IOUG Cloud Computing Special Interest Group, and he has been awarded the IOUG Innovator of the Year Award, and also was named as Oracle Cloud Magazine Oracle Technologist of the Year Cloud Architect. Welcome, Kai.
Thank you. Thank AnDOUC for the opportunity to present this TechCast. So so today's topic is about how we leverage vector in the generative AI. So quick agenda. We'll start with the vector. What is a vector? Then we'll discuss how Oracle implemented vector inside Oracle database. But then we're going to touch a very important topic: how we generate vector from unstructured data, such as image or text. But today we focus on how we generate a vector from text. Then we combine all the technology together, all the components together, to show how we actually use vector search to create a generative AI application, specifically for the RAG. The RAG stands for the Retrieval Augmented Generative. So first of all, let's talk about vector. We want to start with the basic component. So we know that when we do any search, usually relational database, we usually do structured data. But today in generative AI or even AI in general, machine learning in general, we deal with a lot of unstructured data. So that brings a challenge, because in a lot of machine learning or AI or neural network, internally they deal with data. They don't directly deal with image or text. So in order to leverage all the algorithm, inside of the machine learning or the deep learning, you actually have to convert the data into numbers. So that's one reason. Second reason is if we want to convert, we have to make sure that any representation, like a number representation of the structured data, catch the semantic meaning of the data. So, for example, we want to be able to catch, for example, if we want to catch a text, we want to be able to catch all the meaning of this text. Image, same thing. So, for example, if we want to catch this house, so we want to have some way to catch this house. So this house has many different features. So it is natural that we use a vector to represent that, because the first is vector is a number, consists of number. The vector can have many dimensions. Each dimension can describe one attribute. So more dimension and more accurate to catch the meaning. So that's why we will introduce the vector to convert. So we can use the vector to convert any unstructured data into numbers. So that the machine learning algorithm or neural network or whatever the generative AI, large language model, they actually can process or generate it internally. So that's the reason we want to introduce a vector. And the important thing is that when we do search, even in the AI machine learning area, you still have to, we still have to do a lot of search. We have to do a lot of comparison. So the one different important criteria for search or comparison is how do you know these two items are matched? So that's the first one. Okay, so yeah, how do you know this item are matched? So we use this called similarity. So this is actually the diagram to show. So a tiger is close to this animal, close to this animal group, is far from the plants or city. So we use a distance. This distance has a semantic meaning because this is a different group. So when we use a vector, not only we convert the object into number, we also can use a mathematical representation to describe the similarity by using distance. So you can see the distance, the similarity converted to in these mathematical numbers. Of course, right now we're using 2-dimension or 3-dimension, but in reality, we have a multiple dimension. So, but it works the same way. So that's how we do search. If we know how these two vector match, then we can do search. Another question is, we mentioned we want to convert. How do you convert? That's another thing. The technical term for the convert to unstructured data to embedding to vector, the technical term is called embedding. So this embedding process, right today topic, we will focus on how we convert the text into the vector, but the same principle apply to the other unstructured like image or audio. Same principle, but the algorithm method could be different. So that's kind of a general concept about the vector. So this vector already existed before Oracle implement. So academic already done a research on vector maybe 10 years ago. So, but let's see how Oracle implement that. As a matter of fact, the vector has become the number one important feature that introduced the Oracle 23 database. We all probably remember there was actually a version called 23C. Why we change to AI? What is the difference between the 23 AI and 23C? Vector search is the feature that make a difference. As a matter of fact, Oracle actually delayed the 23C AI for half year release because they want to implement vector. So that's why you know how important the vector feature is. Let's take a look at what's the Oracle approach to implement this vector. So before Oracle implemented vector database in the industry, there are many vector databases around them. They already done successful story, but most of the database they only focus on vector, only focus on unstructured data. So how do you know if I want to do some search? That search can search the unstructured semantic as well as the structured data. So for example, if I want to buy the house, I want to know, I want to buy this type of house, but I also want to know or make sure the house has a specific location or price range. And zip code, price range, location, those are the structured data. But the style of the house, the picture of the house is unstructured data. So we want to make sure that all this kind of criteria can fit into a single query. So that's why the Oracle approach was implemented one data type called vector data type. That vector data type is a column, become a column or table. So in this case, I have this column, this column that represent the style of the house. Then I have ID or I have other structured information. So by doing this way, I actually can do the database search. That the search criteria, the workhorse can combine structured data or unstructured data. And Oracle also implemented this conversion because internally vector is stored in different way, but this is actually mathematical representation of vector. That's how human can see it. Oracle also implemented vector underscore distance function. So this function help us to calculate the similarity of the distance. Underneath, there are several ways to implement distance, and this is up to your choice. You can have a cosine distance calculation, or you can have incline this distance calculation. You have a multiple way to do this calculation. When you define the vector, when you define the vector function, this is the parameter you actually can choose. Either use this one or use this one. So here is some example. So by doing this, we actually can combine we can put this vector into simple select query. Here's the example. If I want to select it, or of course, this is kind of just make this thing simple. It's a two-dimensional vector. If I want to find the vector that close to my close similar to my criteria. For example, I have this house. I know this house, the feature. I want to select it in my vector database. I want to find the top 3 houses that are similar to my house. So here's a simple query. So you can handle that. Of course, because this table, in this case, we only selected group by the function, but you also can put a workhorse. Put like, for example, the vector. If this table has other column like ID or price range or location, we also can put it in the workhorse. So by doing this way, we can have a simple select statement that retrieve the vector from vector database, combine the vector the unstructured criteria as well as structured criteria. So we actually mentioned in this example, this is only 2 dimension, but in reality, if you want to describe something complicated, for example, like a house, or house is probably a simple one, but if you have a paragraph, you want to store the paragraph, convert paragraph into database, most likely the vector for that paragraph has probably not going to be the 2 or 3 dimension, could be like end of 1,000 dimension. So, and your database maybe have like 100,000 millions of vector. So in order to have a faster search, we have to implement text index, just like we do in the Oracle database. So we don't want to do like full table scan. So the index is the one way to actually, similar to relational database, the index is the one way to actually speed up your select. So the idea is we want to be able to actually build an index on that vector column. So when we do search, Oracle actually have can find that index, and you, instead of scan every vector, they actually can group make this vector search much faster. So for example, make this much faster. So there are actually several ways to do that. So neighboring vector or hierarchy. So the idea also neighboring partition. So for example, like for this case, so if I want to search tiger, I want to find the closest tiger. I want to just I don't want to just search everyone. I want to make sure that I can jump into this group first and then find the closest the animal. So the other thing, like for New York City or the city or plan, I don't need to scan that. I only need to scan this group. So for example, if I can just jump into this group and then inside the group, I can find the most closest one. So for example, elephant or wolf in terms of size. Or if we want to just how to look, maybe you just catch it like a cat, a lion. So in this way, you can make the search much faster. So Oracle has this very nice vector search live lab. You actually can go to this link. What this live lab does is actually, if you go to lab, they actually create the container database for you. The container called Podman is basically give you operating system, give you a database. So they actually load all the data, so you can explore, can write a lot of query. So I would recommend you can, if you are interested, you can come here. So, this is 23 AI database. You don't have to build it yourself. Of course, you also can practice this vector database in the autonomous database. So if you go to even autonomous database, the free version, they offer 23C AI, you can explore that. But if you try that, you actually have to load your own vector. But this live lab, they already preload all the vector data for you, so you can do the select. Either way, you can actually practice this vector. The important thing is the how to create vector table and how to use the vector distance function to do search, to do select statement. Let's jump into very important topic called embedding. So specifically, I want to talk about how we do embedding in Oracle database, which means if we so the idea is if you have a text, if you have an image, if you have the audio, how are we going to generate a vector for this object and store in Oracle database? So that's the concept. Right now, for this presentation, we'll focus on the natural language, into specifically the text. So there are actually three different ways to do that. The first way is if you let's say if you already have the vector generated somewhere, you actually can export into CSV file. Then you can load it into database. Use a SQL loader or use the external table. Just treat it just like a regular CSV format. But most likely, if you don't have that, if you just start with the text, let's say if you have a sentence or you have a paragraph, text paragraph, how you want to convert to the vector. So underneath, so let's jump into this one. So underneath, the embedding process is actually very similar to actually the coding process. Is change the process, map convert your text into the numbers. So very similar to like coding. Like for example, if you use a telegram, you have a sentence, you want to send the telegram to other side. Internally, you have to convert that telegram into the Morse code, then send the other side. In other side, they actually do reverse process, convert the Morse code into text. Similar way, so embedding process is the coding part. So basically, convert your text into code. But other part, when you convert those code, then AI or generative AI actually do a lot of processing and get some result. And that result is actually still not vector, but we have a process to convert back to text. That is the process, large language model. So the embedding process, a large language model, they are very similar, deep learning model, but they just do opposite way. So So fortunately, those models already existed in Hugging Face. So you actually can, in order to do that, you actually have to get that model into your database. So there are two ways. If you can easily do you have option to actually send your data to the model, like Hugging Face, where the Hugging Face actually already store that model. You can send your text to Hugging Face and let Hugging Face run this embedding process for you, and then send the vector back to you. So this is the process. Uh, uh, but this process, disadvantage of this process is you actually have to send your text outside of your data center to the Hugging Face. So if you have a sensitive data, if you have all the sensitive information or your tree secret or any secret document, that's not good option because you never know if there's any security leak. So this is the option, but so the preferred option is actually we don't want to send the data. Instead of send my text into the Hugging Face, we want to get a model from Hugging Face to our database so that data will not go out. Then we want to be able to actually process the entire embedding process inside database. So first step is we want to get that model from Hugging Face to your database. So fortunately, Oracle, OML, Python, they already include that the Hugging Face model. So if you run this very simple Python code, you actually can load your Python because this model is already embedded into this Python um, package. So if you run this Python code, automatically load this model into your database, or they actually can export to file. So that's the one process. But Oracle did a further one more step in, I think, last September. So you don't have to run this code. They actually pre-process this the model into Onyx format and store it in somewhere in the Oracle Cloud. That's this link. So only thing you have to do is actually run your Linux command, just or just download it, even your laptop. Download this, go to this link. This link, it's actually internal object store you can see this link in the OCI. So they store that file into OCI. Then you just download it. When you download it, you just unzip it. And part of unzip there's some README file, but the important thing is this Onyx file. So this is a regular OS file, and you store the file in your database server. Then in specific directory or we all know that UTL directory. You store the file, you declare this UTL directory. That directory store that file. Then you just run this command, run this PL/SQL package, PL/SQL procedure. Then you you basically load this model into a database. Once you load this model, you can do the embedding inside our database. So data will never go out. So here's the process, right? So it's very simple process. Once you have a query, then I can convert your query into vector and search. So here's a very simple quick case. Let's say if I have a query, I want someone have a query. Let's say if you have the data about Oracle manual, like Oracle 23C AI manual. So if you have a question, specific question, how we create a vector table, this question, then this question will take this vector process will take literally your question, the text of the question, convert to vector, then take that vector, go to vector database to search, to find based on they do the search, use the vector distance search, they find those paragraphs that actually can answer your question. So here's a very simple code, like this case. So this code is just like just the implementation of this paragraph. So I have this simple code, the PL/SQL code. I take my question and So here's this, take the question, then convert your question into vector, the vector stored here. Then we take that vector, run a select statement against your vector table and find the answer. Find several paragraphs to answer your question. Top 4 paragraph answer your question. So this is just an example. So we mentioned that for small sentence, that's easy to convert. But we just mentioned that if we want to do search, I also prefer that my database also has the vectors for the entire menu. So for example, if I have an Oracle admin menu, Oracle 23C database administration menu, which has about like maybe 700 pages. So I can just create one vector to represent the entire book. So instead, we have to split the entire book into different chunk. So that's called if your menu is a PDF file, we actually first have to convert to text, then split the entire book into many chunks. So if we set the chunk size is 512K, then most likely the entire book menu will put maybe several thousand chunks. So that's the process. Actually, they call pre-process. So we have to convert to chunk. Once we convert a chunk, then we call the embedding process, convert each chunk into vector. So that's the process. So right now I'm actually moving a little bit moving close to build a rack application. This is actually an essential step. So if we want to build a chatbot type of application, answer any Oracle question, any question, like for example, if I want to build a chatbot application to answer any DBA type of question. So first thing I want to do is I want to actually embed the entire DBA menu or other document into stored in the database. So this is the process. And Oracle actually has a very good presentation talk about how to break that chunk. It is very important. Think about it. If you didn't break the chunk correctly, or if you just do it very mechanically by fixed size, chances are the specific paragraph that answer your specific question could be split into 1 or 2 chunks. So, but your select statement probably only selected partial 1 chunk, which only can answer partial question. So you end up your question was not your question was not complete. So it is important to actually have several ways. So here's the good presentation talk about a different way, fixed size or combine the semantic chunk. So we group by paragraph. So for example, I have a question about how to actually configure ASM. So we can split it. We can just create a chunk for this specific topic. The chances are, if you do that, then if someone has a question about ASM, the search engine will pick up the chunk that has all the answer about the ASM, because there's in here you don't break the chunk. So this is a good presentation talk about that. Okay, now let's talk about how we use vector search to create a retrieval argument generation. So we all know the large language model. For example, the ChatGPT. So if you have a question, you can ask ChatGPT. In this case, I have a question about the North Carolina last November, North Carolina, the flooding. So I asked a large language model, ChatGPT. ChatGPT answer was I don't know, because the large language model behind the ChatGPT was built. They actually built before the North Carolina flooding. So of course, the knowledge that feed to build a large language model doesn't include this specific event. So that's why if you answer the question, the large language model will not know this. Similar, so if you have a large language model deployed into your local, like say, if you want to use large language model answer 23C technical question, they may not know, because when they train the large language model, they didn't use the specific like 23C AI document. They may use the previous one, but not latest one. So in order to do that, you need to actually feed your latest information that was not included initially in the large language model. So this is called retrieval augmented generation. So you actually can bring the data, bring the information to them. But the question, how to do that? So that's how the vector come in. So if you have an additional document, for example, if you have a 23C AI document, so you actually need to convert convert the entire document into the vector database. So let's see this. If I have a question about 23C AI database, then I have this question to my chatbot application. Then I'm not going to take this question to ChatGPT, but this question will come to the vector database first, because that vector database already has the 23 AI content. So do a search and find the answer to your specific question. Same way for North Carolina case. So I may feed some North Carolina flooding information to vector database. Then when people come to answer this question, they will get the answer from the private data. Then when they find those data, find a match, then when they find a match, the data itself, the result itself is vector. It's an answer to the question, but internally it's vector. Then I turn this vector to large language model. The large language model we mentioned before, do decoding. So take whatever answer, the vector of your answer, and convert back to, or decoding back to text. So that's why large language model take your vector of your answer and map back to text. So return text for you. So that's the loop. So similarly, I do other way around, same way. So I already have all those the vector about private information. Then if someone has like, for example, specific question, but in this case will be like a insurance policy. So I already feed all the insurance information to this year insurance information into database. Then if you have a question about a policy, the question will come to vector database, search, find the paragraph, the vector, and then this is the vector. Then take that vector, feed it into the large language model. The large language model will decode your vector into text. And so that's the process. But let's take an example to see that. So this is actually a little bit, yeah. So in this case, idea is very similar, but we'll see how actually Ender needs to use that. So first, let's say if you have if you want to build the Oracle DBA QA chatbot system, of course you have to do is load all the 23C AI element or performance tuning, all the book. You load the book and this document loader load book and do a lot of chunking. Sometimes you do similar summarization. Then you actually use the embedding model to actually convert that into vector. So in this case, it will be like 100,000 vector stored in the database. Then once you finish this process, then on the other side, as user, let's say if someone asks some DBA question, they can just bring the question. The question will be converted into vector and come to a database to search it, find the related vector that can answer the specific question. Then when they find those vector and send a vector back to a large language model, and large language model do the reverse process, which is decoding process, convert the vector back to the text and generate the text for you. So that's the kind of a concept, but I kind of list it here. So same way. So you have a text here. You load it, your text or PDF file, convert PDF file to text and you load it. Then you bring to many different chunks. Then you use a large language, use the embedding model and convert into do the embedding process and convert it into vector, store the vector store. Then when people have a question coming here, they ask a question. The question itself will be convert to vector through the embedding process. You can see the two embedding process. Embedding convert your document, your base, all the content base. Also, same way you do embedding process, convert your question, because your question or your content originally are in text format, but in order for us to do any processing, they all have to be converted into vector. So this is embedding process. Then we take the embedding and come to the database to do search, just use distance to search. And the final answer, the answer sent back to a large language model. And the large language model convert that vector back to you, which is the answer of the question. So bear with me. This is actually sample code. Left side, I just want to actually highlight some code, but this is the original code run on the notebook. This is actually the Python code. So first you just take a PDF file, read it. The second one, you just use convert extract the underscore text, basically convert this text into a PDF file into a text file. So multiple pages of text file. Then there's a split the character text split function, basically split into different chunk. So you just here you specify the parameter. We just mentioned how we want to split it. That's also important. So these options are very important. Size, kind of overlap. So those options, those parameters directly determine how accurate your answer is. So in reality, you probably want to try a different combination, see what's the best way to do that. But anyway, here's the function. You call that. Once you call that, basically the chunk itself is an object. It's a Python object that include all the chunks, text chunks. So so here's a sample code to do that. Then next thing is we want to convert that chunk. So you have maybe 3,000 or maybe 100,000 chunks. So we want to convert all the chunk into a database to vector and store in the database. So we mentioned before, you have a multiple way to do that, but anyway, you have to get the embedding model here. So you can get some embedding model from Hugging Face. So you can do this is just a one option, but you can have a multiple option. You can just send your text into OpenAI if you don't have the model here, or you can download the model to your database to do that. So here's the one way. In this case, I think this specific example, they actually send the model into the Hugging Face. But anyway, the converter, important thing is that when they convert here is actually the table, the store all the data. This is actually the store all the data into this table. So this table has all the vector. In this case, the chunk become the vector stored in this table. They also specify the distance strategy. This is also parameter. From now on, when you do any search, they're going to use a product to calculate distance. This is a very important parameter to determine how accurately you select it. So once you have selected, you generate this table. You generate this the vector. You actually can do search. This is how the vector looks like. Here, left side is text, right side is vector. Then the next thing is we want to answer your question. So you take that question, So this is just simple question, answer your question. Then question itself will actually store into this user question. And here, the result chunk, yeah. So this is actually result. So the question right now is stored. It is stored in this user question. Then it's vector. Then take the vector, go to go to the database to do similarity search, and then return is the result, the chunk. So let's say if you have 100,000 return chunk, but your question is specifically how to create ASM, they're gonna go to the database to find 3 or 4 chunk that answer your question. So the answer is here, right here, result chunk. This is a list of the vector stored in here. Okay, so next thing is we want to actually use a large language model to convert back. So in this case, you actually have to send the result to the large language model. You can do Meta Llama model. So this is one way to do that. You actually can. This is actually run inside of OCI because OCI Generative AI provide us a service to connect the Llama, Meta Llama index, Llama language model, or you can use coherent. So you have 2 options. But either way, you actually have to use a REST API to send your chunk to large language model, and then they're gonna send it back result. So, but here we just specify large language model as a REST API link, but there's an important concept called LangChain, or here is actually put an answer your question into template. So important concept, I just want to touch a little bit. LangChain is actually important because we mentioned there's several steps. So you have this question put into template. You also have your vector search. So the process you get your question, you go to vector search, then get your vector search into a large language model to convert. It's a step by step. So in order to do one step by step, what's a good answer? Idea is you put into actually a pipe. So just like a Unix pipe, you probably remember in Unix you can run several commands together. So first command output is the second command input. So in this way, just one pipe can finish this whole process. So here is the pipe. So this is the code. You retrieve this data. You fully retrieved it. You get a prompt. So then you send it to a large language model. Then do processing. So this is a single process. Actually, do all the process at all. So it's very. I want to explain that because it is very efficient to run that. But the first time when you learn it, it's actually pretty challenging to understand it. But you just have to understand it. This is actually consolidated into the several major steps, consolidated into one workflow. The workflow is implemented in a LangChain. So here's one. So when you run this, here's the Python code. This actually generates the answer for you. So here's just an example. But I leave a lot of detail. If you have interested, you actually can go to the Oracle OCI AI, Generative AI professional class. They actually give you a lot of detailed discussion about how we do large language model, how to do LangChain, how to vector search. But I just want to give you a highlight, just use this example. Maybe I jump too quickly, but there's a lot of detail behind the 6.5 hour class behind that. I would recommend it. You take the class, and it is very, very helpful. It took me like 2 weeks to finish that class and also pass the exam. So then overall, this is the process. Of course, I didn't do a whole lot of index, but there's when you create an embedding, you also can do a lot of in real application. You want to once you build the embedding, the vector database, you want to build index. Then you do query. So this is actually this side is the user part. This direction is actually create your vector database content, and this is the QA part. So just conclusion, we talk about a vector, why we want a vector, and how Oracle database implement vector, and also what's the best way to do embedding inside Oracle database. But we also use the example to show how we put all the things together to create a simple chatbot application. The application itself is simple, but it actually represents a lot of important technology, which is kind of similar to in a real production system. So that's all I covered today. Hopefully this helpful, give an introduction, but behind there's a lot of technology behind it. I would recommend it, or I would definitely encourage you if you are interested, go explore more. Thank you.
Thanks, Kai. Excellent presentation. We've got some questions coming in. So give me a second and I will start getting those over to you. So
Okay.
first question is some additional links. Is all the code in Python by Amin Adatli?
That is the idea. Of course, if you want to just do simple search, uh, like for example, this example. This example, right? Simple search. Uh, you don't have to do Python because all the embedding process are already preloaded. We mentioned that all this is just a pure SQL or OS command or just a pure SQL code, pure SQL block. You don't have to know the Python. But if you want to build an AI application, just like we had a last example, especially if you want to talk about large language model, yeah, you do need have some knowledge about Python. And the Python itself is not difficult, but Python is very powerful application. My maybe some part can be done by Apex. So maybe Jim can get a. Myself, I have not done a whole lot of Apex coding. I think you also could have option to do a lot of things use Apex if you are database kind of Oracle developer guy. You could do that. But Python definitely, if you want to deal with a more complex AI generative AI application, you probably want to get to know Python.
So Kai, I have a follow-on question to that. And before I ask it, I'm going to encourage everybody to put your questions into the chat and we'll get to those. Follow-on question to the Python question. When I was looking personally at the prerequisites for the AI certification from Oracle, it did have Python as a prerequisite. Would you recommend that, it's definitely a good idea to explore the Python prior to doing the AI certification, or, go ahead and jump into the certification, or what are your feelings there?
Oh, that's a great question. Yeah, I remember they mentioned a little bit about Python, but definitely I would think you don't have to be Python expert to
Okay.
pass the application. And a little the code, the inside of the content, the class, in the end, they actually have a very complex example, actually more complex than this one. They use all the Python. So
Okay.
I would think like you don't have to be efficient to write a Python code, but if you can read through the Python code, I think that would
Okay.
be good enough.
I mean, if I was to summarize your feedback for us or your advice for us, it would be Python's not required. Ultimately, if you want to take your, AI work to a higher level, then Python would allow you to do it a more sophisticated approach. But there is other ways to do it, without that expertise.
Yeah, definitely. We also have that. I totally agree. We also have to understand that in terms of data, if you are doing like a lot of data processing, actually the SQL language is more powerful because you actually do a vector behind it. Python, for example, if you want to deal with a lot of database table, Python itself, you actually have to build a lot of object. You have to worry about how to connect the database. But a
Okay.
SQL, pure SQL is much more powerful, much easy to use, at least for us. But maybe not for those Python engineer, but for us, it's much more powerful, simple. If you want
Right.
to like do some cleansing or find some null value, that's very powerful too.
Okay.
Yes,
We
SQL.
got a couple more questions. Tomislav Osurek has asked it all can be done on a free tier. Can all these things be done on a free tier?
Uh, yes, but uh, Uh, in the vector search part, yes, but for the more complicated application, uh, could be challenging. I haven't tried the free tier yet, because I
Okay.
use a lot of the live lab. So that's a good question. So because I understand that so if you use do some especially if you use OpenAI, if you use a large language model, they may not be available. So
Okay.
yeah. But all the vector search part, especially embedding, the all can be done in the free tier. But
Okay.
yeah.
Okay, we've got a couple more questions. The next question from Ben Zhang is in the demo, we see a Python example to build RAG using a PDF. I think you've answered this, but can it be done using PLSQL to convert PDF to text, chunk text, and convert the chunk to vector?
Could be. I have not tried yet. Yeah, but if you find any like a PL/SQL package to handle that, definitely yes. Yeah. So
Okay,
this example is kind of a little bit old. So yeah, if you find some, I think there's some package to handle that. Yes. Yeah.
excellent, very good. Now, next question from Richmond Osamoa. At what point will the AI not answer your questions?
That's a good question. Uh, we have tried a lot of things. Like for example, uh, as we mentioned that in order for AI to answer your question, the system has to have the knowledge about domain knowledge about area. So if they don't have no domain knowledge area, either they not be able to answer your question or this concept called hallucinate.
Okay,
So yeah, so they may answer some question wrong way. So yeah, so as a matter of fact, the RAG itself is actually one way to actually reduce hallucination. So yeah, so that's why I didn't mention that, but definitely it is important. The AI system is not magic. You actually have to feed them the information. The reason the large language model can answer most of the question was because they scan the entire internet, find as a space to find the answer. But
right.
if at that time the knowledge was not exist when you build a large language model, of course they don't know it. So
Yeah. Next question is, does 23 AI support hybrid vector search?
yes,
Yes.
yes,
Okay,
yes, yeah.
next question is, the code you have showed is something that I can run on my local laptop, exclamation point. But imagine I have to deploy this and say, call this from, say, Apex or VBCS. How can I do that? Where should I deploy the code and how can I call that as an API?
So if you look at the code, so for this part, so I look at this two part. First, this part, this kind of code, right? Uh, so PLC go code. So definitely you can run your laptop. Uh, as long as you follow the you down important in order to get this code working, you actually have to run Oracle 23C AI. You also have to load the embedding model for you to get it work. But if you want to get a more complex code, especially you have to deal with a large language model, important thing is most likely you won't be able to do that because they actually call there's an OCI Gen AI. You probably see that OCI Gen AI. This is the
Mhm.
OCI feature. So you have to use it. You have to most likely you have to run inside of OCI, or if you have other way to to get the meta to working. So either use it. So just this is the endpoint, right? So in order for you to access the large language model, you can easily use OCI large language model, or you if you run other cloud platform or your laptop, you actually have some way to direct contact, connect to the Meta large language model. Of course, you can.
Okay,
Yeah.
we got a couple more questions, and this one is really nice. I was thinking I'd like to know the answer to this one myself. Nasir Rana asked, can you automatically create the index of a book using this approach? Does the book need to be in PDF? And what other formats are supported?
Oh, okay. Okay, that's a so if you look at this format, right? So this format, right? So so create indexes is right here. So you are actually, yeah, your question is that if you have a PDF is run here, you actually have to convert, first of all, uh, no matter if it's a text or format or PDF, you actually have to create it into vector first. So right now we're talking about a vector. So so I guess if you want to use a vector database, you actually have to do embedding first. Then we build index.
Excellent. Couple more
Yeah.
questions. I don't know if we'll get to all these folks, but we'll do our best. Is there any fine-grained control over the vector mapping? An example, if I am building a tool to answer cancer treatment questions, choosing a set of vectors that can also differentiate cupcake recipes and song lyrics meanings, we are only using tiny portions of the vector space gamut and perhaps losing some important granularity. From Simon Clark.
Yeah, I don't know the specific area, but I would think the embedding process, they use the embedding model, but there are actually quite a few parameter, a lot of parameter you can actually tune. And also, and the chunking itself is also very complex because if you relate all this, probably chunking itself, how you do chunk is a direct determine the quality of your answer. So we talk about chunk. There's actually a lot of parameter, a lot of method. There's multiple method. Each method they actually have a lot of parameter to do it. So it is good important. It is a good idea to actually tune it, try different paths.
Ben Zhang or Rich Osama was kind enough to give us a link to Ben Zhang's, I don't know if it's a blog or what it is, but you guys want to check that out.
Yeah.
Louis
Okay.
Menzel, what exactly is the meaning of quote unquote training on large language models? I don't think we were talking about training. He was talking about training on. Oh, yeah. Can you talk about training the large language model for our audience?
Oh, okay. So I guess like training you mentioned that. So when you have a large language model, you actually have several ways to do that. Initially, you build a large language model. This is the entire training process, which take about a month. Use maybe 100 or 1,000 GPU to do that. So that's the initial. Or if you have a larger change, like normally this has been done by like OpenAI or maybe done by Llama by Meta, right? But you also can actually tune the fine tune process. So tune the larger language model. So compared to initial training, the fine tune is actually take less CPU. The fine tune is also can adjust a lot of weight inside. We all remember that in large language model there's a parameter like I think the one of the large language model has like 70 billion, right? So the fine tune basically is kind of add some additional parameter to make it more accurate. But RAG itself, the difference from the RAG and the fine tune is RAG itself does not change large language model.
Okay.
The fine tune changed it. RAG basically add additional data. You can see let query select, go to vector database, find the answer first, then go to large language model. But they didn't touch large language model.
Excellent. We got one explanation. Richmond had suggested or said that this is an example of his work that he had given here at Binzang. We got two questions in 2 minutes. We're real usually don't take our tech cast this long, but we got great questions. Quick question is, can we deploy the Python code as a data science model or deploy that on a VM and call that as an API where I send the query as the input body of the request?
I'm sorry, I didn't fully understand
Okay.
this question.
Yeah, I'll tell you what, we're at the top of the hour, and folks, Kai's contact information is going to be provided in his presentation, and we apologize for not being able to get to all and every question, but Kai will make himself available, so please look for his presentation to be posted soon. We know you have choices in how to spend your time, so it's greatly appreciated that you join us today. Thank you for your great presentation, Kai.
Thank you. Yeah, definitely feel free to send the question to me. I have the contact. Yeah.
Yeah. And
I
there's some
would like to actually go through. I'm actually highlight those questions and I will answer those questions. I will do some study because this is just an introduction. There's a lot of things behind it. Very interesting topic. Yes. Thank you.
Yeah.
Thank you for this
Thank
opportunity.
you, everybody. Here's
Thank
some
you for the
helpful
great
links.
discussion. Yeah. Thank you.
Thanks, everybody.
Thank you.